Okay, here goes the last video of the chapter. Hopefully this may end up being long, just because they're longer calculations, and to explain it all makes that even worse or compounds the problem. But here we go. A forester measured 27 trees in a large woods. It's up for sale. He found a mean diameter of 10.4 and a standard deviation of 4.7. They said the normal model applies. When we get really picky, that's an important sentence as far as the normal model applies. But right now, everything applies. So here we go. Let's draw this normal model. So again, that normal model is going to start with a mean of 27 in the middle. And then we know that we're going to have 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. And that we can do that. So, wow. Standard deviation of 4.7. So we're just going to add 4.7. We're going to get 15.1 above. We're going to add 4.7 again and get 19.8. We're going to add it again and get 24.5. We're going to subtract 4.7, and this gives me a 5. Why did I get 27 at? Somebody stop me. Wow. Okay. I had 27 trees. Whew. Anyway, we know the mean's 10.4, so we should have started with 10.4 in the middle. I apologize if you're sitting here wondering, what in the world is he talking about? 10.4 is the middle, and now we're going to subtract 4.7, and that's going to give me a 5.7. Subtract 4.7 again, that gives me a 1. Subtract 4.7 again, gives me a negative 3.7. So it's going to be a little bit tough here. I said it did tell me the normal model applied, so it worked, but part of my curve is going to have negative values, so that actually doesn't make sense because I'm not going to have a tree with a negative value. Anyway, again, the central 95, so picking up where we left off last time, we know that between 1 standard deviation below to 1 standard deviation above is 68, and then 2 above to 2 below is going to give me my 95. So that is what we're looking for the central 95. It's going to be 1 inch to 19.8 inches. Okay, what percent of trees should be less than 1 inch in diameter? Now, so let's just talk about that. Again, it fell on a standard deviation for us, so we're going to go this way. So we know that we burned up 95 in the middle, which left us with 5% left over. So that means we're going to take that 5% and we're going to divide that in half. So that means we're going to get 2.5% tail. The next one is going to be 5.7 to 10.4. So we can see that if I highlight that on my graph, or I grab a highlighter tool, we are looking for that area right there. Again, it's one of those things that we could go ahead and calculate this because we could take 68%. Wow. We have 68% in the middle. I'm going to divide that in 2, and I'm going to get 34% was the fastest way to do that. Okay. If we scroll up here and go back, scroll all these pages, remember we had that up here in this diagram here. We had all those percents between standard deviations. We didn't have tails, but we had percents within each standard deviation. So here we go. Whoops. All right. And lastly, what percent of trees should be over 15 inches in diameter? 15 actually didn't fall right on a standard deviation for us, so we're going to take that opportunity to help us out and do a different way. But there's 15 right there, so that is a 1 standard deviation tail, and we just need to get ingrained in our head that that's going to be 16% for that. Now, I am actually going to do this problem a different way, just because I'm going to use it to introduce what we're going to do down the road. Now, the problem is my actual standard deviation was on 15.1. And this was asking for 15, so I'm going to do it a different way. What I want to do is I'm going to find the actual z-score for this, meaning I observed 15. I expected 10.4, and we had a standard deviation of, what was my standard deviation? 2.7? 4.7. Sadly, I don't have my calculator handy, and this is not my current notes, so I'm going to have to beg forgiveness as I stall, as I try to find a calculator app on my phone. Anyway, 15 minus 10.4. And now there's that awkward silence, is 4.6 divided by 4.7. So that is 0.9787. Okay. Now, so far, up until this point, everything that we have done has fallen on standard deviations for us. This is the first one that didn't fall exactly on a standard deviation. It's really, really close. We said it fell at 1, and we used this calculation here at 1 because it's 15.1. Okay, but it's actually 15 is actually at 0.978 standard deviations. So we have a different way of doing this. And it's what we have to use a z-table to do that, our standardized table. So I have posted one of those that it's in the files, okay. But for some reason, there we go. I'm going to flip over here and I'm going to go to formula sheets and talk about how we use a table A where we find the probability. So in this table A, it is showing us, and I'm paying attention to what we're doing here, because it's showing me the probability to the left, okay. Now what I had, so all of these are going to be negative z tables. It's showing me, so let's say for example, this little mark here was a negative 1.64, okay? So that means I'm going to go down here, the negative 1 is going to be down here. I'm going to go down to negative 1, here is negative 1, okay? Actually, I'm going to go all the way down, I'm going to go scratch that. I'm going to go to negative 1.6, which is this row right here. Okay, there's the negative 1.6 row. Now my number was 1.64, okay, we can see that. So that means I'm going to go down the 4 column, and we're actually going to get 0.0505. So that means that 0.0505 means that this is representing a 5% tail, 5.05% tail. Now on the previous problem that we just did, we found that it had a z-score of 0.978. Why did that disappear? Wasn't it? So we scroll down. Oops, I can't. Okay, so let's flip back here to make sure that we're looking up the right thing. Okay, it was 0.978. Okay, now we can't go any further than tenths place, so we're going to go 0.98. So as we go back to this, okay, we have to be on the plus side, so we are now going to be over here. And it was 0.98, right? So obviously from a previous class, I've got a lot of clutter here. So let's take out some of this clutter. Okay, so 0.98 is what we're trying to look up. Here is the 0.9. Here is the 8. So it's actually very easy, since it fell on that for me. There it is, 83.65. Okay, now what we have to remember is this is 83.65. Okay. The question it's asking for when we go back to homework it wants to know what is this part. So that means that we're going to have to, the area under the curve is always 1, so we would have to subtract from 1. So we're going to go 1 minus 0.8365. So this is going to be 1 minus 0.8365. And so that means it's going to be 0.1635. So while I estimated it at 16%, it's actually 16.35%. But we needed that because we needed a little bit of introduction into using that table, because that's going to start coming up here. Okay, more cattle, the highest 10% of weights. So this is a perfect lead in, because we're going to have to use that for this one here. We want the highest 10% of weights. So I don't like what to do. Let's do this. Let's do a highlighter instead. So what we're talking about is we want the highest 10%. And if we think about a curve here, let's go back up. Let's find a curve. All right. If we think about that highest 10%, past 1 standard deviation. Sorry, I'm going to find the right tool. Up here, okay, 3 standard deviations, it's only 0.15%. If we do this together, we throw in that one, it's roughly 2.5%. And if we throw in this one, it's going to be 16%. So I want the top 10%. So I know that I'm looking for a tail, but it's going to fall between 2 standard deviations. So I don't have, it's not being nice and neat for me, it's going to be require me to do some algebra here. So here's what we need to do. That standardized table that we were just looking at, okay, I need to know what is the z-score for 10%. That's what I'm trying to find. Okay, so I need a z-score for 10%. So we're going to flip back to that table. I am going to go to my table. Now, so that means I'm going to have to scour this table for 10%. So I'm going to be back up here. I'm looking for a number closest to 0.1. And as I go across here, there's 0.0968. Here it is. Here's the number I want. It's 1003. Now again, if we follow that, I follow it over to get a negative 1.2, and I graze up, that's an 8. So that number is, that z-score is a negative 1.28. Now hopefully you're saying that doesn't make sense. So let's go here. Remember, we got a z-score of negative 1.28. So the z-score for 10% was negative 1.28. But if I look over here, this is clearly not a negative z-score. Negative 1.28 was going to be somewhere over here, and that's because we looked up, when we looked up a z-score, we looked up 10%. So remember, there's also a 10%. My table is showing the area to the left. So it's okay. It's negative 1.28 is still completely usable because my curve is completely symmetric. So that means I'm going to use a z-score of positive 1.28. Okay? And now it's going to be algebra for the win. We've done this before, okay? Meaning we have an observed value is unknown because that's what I'm trying to find. It has a mean of 1152 and it has a standard deviation of 84. So now again, it's multiply and add. So I'm going to multiply 84 times 1.28. We have to multiply across here. We're going to add the 1152 over, and we're going to get an x value of 1259.52 pounds. Okay? All right, the lowest 20%. So this one will be nicer to us. We want the lowest 20%. Now, remember that, here, let's do this. Here's my mean of 0 in the middle. Here's one standard deviation below, and I know one standard deviation is 16%. So I know when I'm talking about I want the lowest 20%, we're going to be just a little bit inside that. So as I'm estimating what my z-score is, okay, I'll make that a different color. I need a z-score right here at the blue line. Okay, I know it can't be, it's not going to be less, it's going to be around -1, but not quite there. Okay, so out to my table, I need the lowest 20%. Okay, so again, I'm trying to find a number that is closest to 0.2. Here is that guy right there, 0.2005. As I go to the left, that's a negative 0.8. As I go up, that's a 4. So that's a negative 0.84. So my z-score is going to be a negative 0.84. So negative 0.84 is going to equal x minus 1152 all over 84. Again, it's algebra for the win, but if we do that, we get 1,081.4 pounds. Okay. The next one gets uber difficult. Okay, because if we think about this, it wants to know what the middle 40% is. So I'm going to find an area here in the middle. Okay. So let's split that in half and talk about what that is. So that's the middle. That means that this percentage right here, I'm going to have 20 on each side to be the middle 40%. So that means that if there's 50% on one side, I'm really trying to find the lowest 30%, okay, is what I'm trying to find. However, I'm going to show us another tool that we have. Hopefully by now you've gotten a calculator, so I'm going to swipe over to my calculator and talk about how we're going to do that. So that would be YouTube. Here, we'll just go this way. All right, so here is that calculator. This is Calculate 84. If you look on the left-hand side up above, there's an online calculator that I showed you how to get access to. This is Calculate 84. We would go stat. Oh, we're not going to go into stat. My wrong place. We're going to go into distributions. You can't see me pointing at it, but it's right above your vars key. So we're going to go second and vars and get into my distributions. Okay. I'm working backwards because I'm trying to find a value of x. So we're going to do number 3, an inverse norm. Okay. And when we do inverse norm, we can actually type that in there and it will tell me everything. So on this last problem, we decided actually we needed the left 30%. The mean mu comes next, so now I need to know what the mean of my steers was, and that was 1152. And I ended up with a standard deviation of 84, so we do that. So we hit enter, and that came back at 1107.9, okay? So if we scroll over to this, by using an inverse norm of 0.3 and 1152 and 84, it took everything out of the equation for me. It found out that that steer weight is, I forgot what it was, 1107.95. Okay. So, and then I would have to do that again. And because this is the bottom, now it depends on your calculator. So this is going to be the bottom 70%. So I'd have to do it again with 0.7. And this is why this problem is really kind of icky, because we're going to have to do that twice. But the calculator allows us to take out the algebra. We can enter the mean. Now, if I just wanted a z-score, we would inverse norm the bottom 30% with a mean of 0 and a standard deviation of 1. So this is for a z-score. But if I put my mean and my standard deviation in it, it takes me all the way back to a percent. Anyway, I need to go do this real fast. 0.7. So I don't know if I can change that into a 0.7 or not. Second and entry, and I'm going to back this up to 0.7. 1196.05. When I switch between apps, sometimes it doesn't like to do that. Okay, so there we go. That's how we're going to find the middle for. Now, if you're actually using a TI-84, that guy, you can actually do a middle area, and it will do even nicer things for you, but that's all we have. Okay, we have this one more page left of cattle, and so we will attempt to get through this the best we can. So I will work this 2 different ways. Method number 1 is, again, we're trying to find the 40th percentile is going to be, I want the bottom 40%. Okay, so 40% down there is what we're looking for. So when I go to my calculator, actually, I need to know what 40% is. So if I looked up 40% in my table, I'm going to get a negative 0.25. And the observed value is unknown. The mean is 1152. The standard deviation is 84. So that means that if we solve that, x turns out to be 1131 pounds. Method number 2 of doing that would be inverse norm. When we inverse norm this, we want the lower 40%. So we're going to go with a 0.4. It has a mean of 1152 and a standard deviation of 84. So that's our 2 methods of doing that. And we're going to get roughly 1131 pounds. Actually, we'll jump back and do that real fast. Make sure I'm actually, when you get the exact value here. So what we're going to change this to 0.4. So 1130, 1130.72 actually. So we can get a more precise answer using our calculator. All right, the 99th percentile, so the uber heavy cattle, the uber heavy steer. So usually if we were taking the AP exam, we would be drawing a picture on every single one. Obviously, I can't tell you to do that. However, I just would encourage you to take or draw a picture. We want 99%. We would have to find a z-score for that. I will cut to the chase. It's 2.33 if we're doing that. Observed is unknown, 1152 with a mean of standard deviation of 84. That algebra kicks in and we get 1347.72. Personally, I would be using the inverse norm feature on my calculator. We're going to do the bottom 99% with a mean of 1152 and a standard deviation of 84. Okay, that's what I would be doing. What's the interquartile range? So let's talk about the interquartile range for a second. If we go back to that, remember that we could take a set of data, we could divide it in half and get to the median. We could divide it in a half and half again, so we get quartile 1 on the left and quartile 3 on the right. The middle 50%, or the middle 50%, there's my interquartile range. If we split up this into quarters, that's 25%, 25%, 25%, and 25%. So the interquartile range is my middle 50%. I don't want that. Okay. So that means that we're looking for this guy here and below. So we need to do an inverse norm for 25%. Of 1152 and 84, and then we would do an inverse norm for 75% and 84. Okay, that's how we're going to do that one. All right. Now, some of the problem, I feel like I almost gave you an injustice on this because we don't have a whole lot. Every single problem that we had in finding a percent was when it fell on standard deviations, and we're going to have one that finally does not. And we only had one to do on there. So what we have to remember is we're going to take X, we're going to convert that to a z-score that we're going to convert into a percent, okay? That's what happens here because we didn't fall on a standard deviation, okay? Meaning, if we go back to this, if we look at the curve that's going to happen on this, there's our curve. Let's try again. A little bit better, not much, okay? We have a mean of 38.2. and a standard deviation of 1.8. So if I come back 1.8, okay, that's going to give us what? I don't have a calculator handy. 38.2, 1.8. It's going to come back at 36.4. So this is 36.4. Now what it's asking me for is what percent of kids do we expect to be less than 3 feet tall? So 3 feet tall is going to be at 36. And so my problem is it didn't fall exactly on a standard deviation for me. So I got to have a different way of doing this. So what happens is I'm going to take this value of X, that X value is 36. I need to convert that value of X into a z-score. So again, z-scores are found by taking 36 observed minus expected. Expected is 38.2, and we're going to divide by the standard deviation, which is going to be 1.8. So we end up getting a z-score of negative 1.22. Okay, so this is where that chart comes in, negative 1.22. We have to look that up in a table. So again, we're going to highlight where we're going to go after here. Negative 1.2 is going to be right here. I'm going to if I highlighted this row, there's negative 1.2. 2 is the other part of that, so that means that we're going to come down this row. And where they intersected at is going to be my number that I want. So that 11, maybe I'll pick a different color to highlight that. The 1.1112 is going to be my percent. So that is going to, we converted that to negative 1.22, which we looked up in the table, and I've already forgotten from the table what that was. It was 0.1112. So I am not for sure what MathXL will want for answers, but there is what we need. It's 11.12%. Now, there is another way of doing that I need to show you just to make life easier, especially down the road. I am going to undo that box. We are going to take and we're going to slide this guy over to here. So that way I have a little bit more room, and I'll change the color so we know what we're talking about. There's another feature on our calculator. What it's called a normal CDF. Okay. Now that normal CDF is, again, if I have a normal calculation, and C stands for cumulative. It doesn't matter that you understand C or not. Okay, we just have to know what operation on that calculator to go find. So I'm going to go out to that calculator. Okay. In that same distribution area, you can't see me pointing at the VARs button, but it's in that same distribution is actually option number 2. It's a normal CDF. Now, some of your calculators are going to be prompting you in line form. Mine, different as you move down a vertical. This one is always horizontal. So what I'm going to do is it says asking me for my lower. So it's my lower boundary. This is a left-hand tail. All right. If we go back to the graph that we were working on, again, where it's going to the left. To make sure that we encompass everything, my left is going to be -1, and then above my 7 key is EE, and then we're going to go 99. So this is like as far left as I can make it. It's an extremely left number. My cutoff then, my upper boundary was 36 inches for that desk. Okay. Now my problem is I don't remember what my mean and my standard deviation was. However, I have it here on paper. My mean was 38.2. And so then I hit my comma key, and my standard deviation was 1.8. So again, it's going to matter what version. This is what I have to do for mine. Okay, it's what if you get a graphing calculator, there it is. Now this gave back with 0.1108. So again, very, very close, but that's what we're going to enter. Okay, so that means this needs a lower boundary, an upper boundary, a mean, and a standard deviation to work. Okay, but that's going to make those calculations much easier than that. Middle 88, tallest 10% of kindergartners. My problem is I'm worn out. I'm tired of doing problems, but we got 2 more to do and we'll get it taken care of. So we want the middle 80%. So I want 80% in the middle, which means that there is 10% left, 20% left over. So that means I have a 10% tail there and a 10% there, tail there. So I am using my calculator on this one straight up. We're going to inverse norm. I have an area of 10%. Okay. I am going to then have a mean of, so I've already forgot my mean, 38.2, and a standard deviation of 1.8. And this is straight up going to my calculator and having it tell me what the answer is. I'm going to do this one on my phone. I'm sitting here if I can find the right thing there. So 0.1, 38.2, and 1.8. Gonna enter that. Pretty crazy. 35.89. So that turned into 35.89. The normal distribution is really great. If we wanted to, we could find the difference, meaning we could find that it's symmetric. Sorry, wow. I know my center here is at 38.2, and I just found out this value down here is 35.89. So if I wanted to, I could just find out what that difference is and just add that difference to the other side. That would be one way to get that center, or I could just inverse norm 0.9 with the same things and move on. So it's up to you on how you want to get that done. I am going to take 36 minus my previous answer, and that is 0.106, and now I'm going to add that on to 38 point. Why did I take 36? Sorry, I completely botched that on my phone. I don't know what I'm thinking. Okay, meaning, if we change colors, I went down 2.31. So if I go up 2.31, that means the other side of this is going to be 40.51. Okay, so you have a couple different ways you can do that. How tall are the biggest? 10% of kindergartners. So we just knocked that one out real fast at the last. We want my top 10%, which is my bottom 90%. So that means I have to inverse norm the bottom 90% with a mean of 38.2 and a standard deviation of 1.8. So I will do that real fast just so we have it there. The area is 0.9. We have a mean of 38.2 and that standard deviation of 1.8. I am sorry, this video probably took forever. Anyway, it's 40.51. But that'll get us through the end. Hope you had a good week. See you next time.